working on the rest of the problems that are in this section. We've looked at geometric sequences. Geometric sequence, again, is something that has numbers that are multiplied by a common ratio as you go here. 5, 10, 20, 40, 80, right? Something like that. Not 88, 80. Okay, that's a geometric sequence. The word series refers to, if you're interested in the sums of those. Right here you have term 4 in this case. Term 4 is 40, right? It's the fourth thing there. This is n equals 4, right? Term 4 is 40. If you wanted the sum of the first 4 terms, that's different. Okay, sum of the first 4 terms. You use the symbol S, S4. What would S4 be? 40, 60, 75. Consider that this is like the difference if you get a paycheck. You know when you get a paycheck, it often, I don't know, I'll draw something here. It often has 2 sides to it. There's a column that says current or something like that. And then I didn't make my paycheck big enough here. Story of, oh, never mind. Current, and then it says something like year to date. So let's say you got, your current paycheck is $500, but several months have already gone by, or weeks, or whatever, pay periods, and it might say 2,000 over here. This might be, if this was your third paycheck in the year, this is like term 3. If this was the third paycheck in the year, this would be like S3, right? If you got paid the first month, you got paid $600, and then you got paid $900, and then this time you got $500. This is term 1, this is term 2, term 3. But S1, S2, S3, those are, if you add up all the terms up to and including that one. Okay, that's more like the year to date, all your pay totaled up together, and this is just what you're getting paid right now. That's the difference between those 2 symbols, and that's the difference between when we use the word sequence and when we use the word series. In everyday language, you use those interchangeably, but in this, we're going to use series when you're interested in the sums of what you're looking at, which I think I have the word there somewhere. There's 2 formulas here for how to find the sum of something, how the sum is related to the other 3 things, and I think I pointed these out to you already, but and we're not going to go through and see where they come from in class here. If you look in the Math 12 textbook or you look online, you can find all kinds of proofs and background for where those come from. But when I've done this in the past, it ends up, I think it does more harm than it's worth. I like you to know where things come from, but I think if we do that for this, it doesn't help. Anyways, this is 2 formulas. Maybe what you should do instead of seeing where they come from is see what's involved. This one has 4 things. It has the sum of the first n terms. It has n. You need to know the number of terms. You need to know the first term. And you need to know the ratio. So for what I gave you up here, this sequence up here, if you wanted to know the sum of the first 200 terms, you could find that without writing them all out. That's the idea behind that formula. Because you know the first term, you know the ratio's 2. You know that if I say the first 200 terms, you know that n is 200. You could plug those numbers into that formula and find that. There's one other one, and this one comes from just making a change here using that Tn formula. Tn is AR to the n minus 1. If you combine this formula and this formula, you actually get this. The last term is sort of like Tn. L stands for, I'm going to write an L like that, last term. It's actually like term n, I guess. But that one, look at what you have. You have the sum, you have the ratio, you have the first term, but you have the last term. You don't need to know how many. This you can find the sum of something if you don't even know how many there are. those two formulas you can use to solve any of these problems. What I would do, I'm going to ask you to go through and work on these. It would help if you made a list of what you have. You can move somewhere else unless you like that seat. It's okay. That's fine. It's up to you. It's fine. You can solve any of these. I think a good strategy for a lot of you is to make a list of what you have. If it says find the sum of the first 7 terms of this, instead of directly trying to write a formula or write it out, it would help to make a list. If you want the sum of the first 7 terms, this is what you're looking for, right? You could say, that's what I want. I know that n is 7. I know that the first term is 3. And I know the ratio is whatever 6 divided by 3 is. 2, right? Once you have a list of what you have, you can choose which of those 2 formulas you can use to find it. You don't know the last term here, but you do know that n is 7, so this one makes more sense. Because that one you need to know n, but you don't need to know the last term. This problem down here, I haven't told you how many there are. N is question mark, but you do know the last term, so then maybe the other formula is more appropriate. You can work backwards. If somebody tells you the sum, but doesn't tell you some of the other things, you can solve for that. And I've given you some harder problems here where you have to do some thinking. Okay, some H-level type stuff. This one's really, I would say, H-level at this point because you have to think and maybe discuss with somebody else what the words mean here after it's talking about a ball bouncing. Maybe we'll pause this for a second. So can you, either on your own or with somebody else, work on finding solutions to some of these problems and then checking and comparing with other people? And remember the binder at the front has some answers at least. Maybe not done the same way you did it, but a sample solution that you can check. Doesn't mean that's the only way to do it. All right?